Hi, welcome to another one of my videos, and it's been brought to my attention that, oh, excuse me, some of you might be having some problems with Unit 2, Worksheet 5. This is basically the last worksheet of our constant velocity unit, and it does present some problems, but it's really nothing you haven't seen before. The trick behind this is not so much that it's a difficult worksheet, but it does have a lack of instructions. So let's consider this a set of instructions. So I'm going to scroll down just a little bit. While I'm at this, I'm just figuring something out in how to do things in Microsoft Word so that I'll be able to do some of these things right in Microsoft Word and you'll be able to see it. So I'm going to go to Review. Excuse me again. I'm going to start inking. And what I should be able to do is start writing on this. So what we have is actually 4 problems here. There's problem 1, problem 2, problem 3, problem 4. Now on the other side of the page, there's problems 5, 6, 7, and 8. I also recognize that problem 4 has an issue. This is very dark and you can't see it. But you can see it on here. So I'm going to use this as my example of how to do this worksheet. So you can still do it yourself, but I'm going to show you the basics of what's going on with it. So let me erase that. Go back to Ink Tools, and I'm going to change this. Oh, I'm going to change the color of my pen. I want a purple pen. Why? Why not? So here's my pen. The idea behind this worksheet is to take one of these graphs that you get. For example, in problem 1, we give you a position or a distance versus time graph. And then what you're going to try to do is to fill out all the rest of the graphs from the position versus time graph. Well, wait a second, what about this one? Well, in this one, we give you a velocity versus time graph right here. And we ask you to do the position versus time graph. Over here, we give you a position versus time graph, and you have to do the velocity versus time graph. And here, we give you a velocity versus time graph, and your job is to do a position versus time graph. So that's fairly straightforward so far, but there's more. We also want you to do a written description. Now, we don't give you any of these here, so you want to describe what's happening. And so I'll give you an example of that in a bit. And then on the bottom is a motion map. And the motion map is the first real time I'm giving you a chance to practice drawing those motion maps. So because that's another tool that's going to help us solve problems, I really encourage you to, at the very least, do the motion maps. The velocity versus time and the position versus time maps are going to be on our exam. So you do want to pay attention to those also. And oh, by the way, the written description, if you understand that, if you can do that, then all of these others will be very easy to do. So let's start with this one over here. This is a velocity versus time graph, and you can see right here the velocity is 0. So I'm going to start by drawing my axes here, and because I'm drawing it by hand, obviously it's pretty bad. Of course, I probably should put a ruler down on my tablet there. And that, actually, I think I'm going to do that. Put a ruler down on the tablet so it's easier to, so it doesn't look as bad as what I was doing. So let me try this. Get a pen over here. Put down a ruler. Well, that works a little bit better. That's not really a ruler, but it's a straight edge. Okay. Yeah, it was pretty awful, but there we go. This is my position. I'll follow the convention and use X. Where'd my line go? There we go. I'll just do that. Okay. What? keeps losing that. This is something new for me, so I'm not sure why it keeps losing that thing. So let me try it again. Maybe I'll just do it up here. I think there was something happening when I was doing that circly thing. Well, in a position versus time graph, if it's not moving, then we can just fill in this part here. Okay? It's not moving. There's zero distance, and I get a horizontal line. There's nothing in the velocity versus time graph that tells me what the original position was, so I'm just going to say that it's 0. Then we have a positive, and it's a pretty high speed, positive velocity. So I'll draw a line that way. And then on this last one, it's a negative velocity, but it's a smaller negative velocity than the first one. There we go. Something like that. And that circly thing is killing me. There it goes. So now that I have that, that's my position versus time. Well, I can go back over here, and I'm going to scroll down a little bit. And written description. Now this one I'm not going to write, but we know that something is standing still for a little while. It's going with a positive velocity for a little while. Then it's going with a negative but smaller negative velocity. Well, that's all you need for a written description, but feel free to actually add some imagination to it. Like, I stood there on the corner trying to make up my mind whether I wanted to go north or south. So I went north very quickly, and then after I did that, I decided no, my going south was a better idea, so I decided to turn and go south. That's a little story that I made up. Pretty lame story, but it helps me think about it, and it adds a little fun to an assignment like this. The last one is the motion map. And motion maps are what we were talking about in class. It's sort of like something is putting down some dots, and then arrows that describe where it is and when it's doing it. So I'll put a dot here saying that we're starting it, it's not moving. Dot there, oh, the little circly thing there. Dots. So for a couple of seconds, it's not going anywhere. Then here's another dot with an arrow going in this direction, and it's a pretty big velocity. Arrows going in this direction. It's not going to like that. Oh, it took it. And now it's going to come back, but a little slower. That direction, come back and a little slower. So that's the motion map of what happened. So if you can do this for all of these graphs, it just is getting you used to using all of the tools, or almost all of the tools we were trying to show you, so that you could much more easily see and solve problems involving physics and actually involving a lot of things. The point is, getting you used to using multiple tools will help you learn to take multiple approaches towards solving any problem. So what I asked you to do for homework, because you really can't see number 4 and on the back number 8, let me just scroll down there so you can see it. You don't need to do those two. In number 8 they do a motion map, but you really can't see it on your screen. You know, it gets too dark on the piece of paper. So just do 1, 2, and 3, 4, 5, and 6. I will be looking for this in the binder. I'm going to do a binder check before the end of the week. I'm going to look for this in your binder, and if you do have it all filled out, I will give you a couple points extra credit on the test that we're coming up with. So thanks for the question on this. Thank you for your time, and I hope all of your problems have solutions.